Well, dear students, till now we have learned refraction through glass slab and prism. Both the prism and glass prism both have plane surface. Now we will study the refraction through transparent spherical surfaces. Actually, this figure shows. Actually, it is a part of glass slab whose surface on which light falling is concave in shape. Then how the image will be obtained and where we will see the object. This is the concave surface of glass or index n. Principal axis, pole, center of curvature of this sphere. Center of curvature of this sphere is this C. O is the object. A light ray along the principal axis goes straight because fall normally. And another ray after refraction bend like this because it is going from air to glass, bend toward the normal. Bends toward the normal, so this is the angle of refraction. This is the angle between incidence ray and normal. It is called angle of incidence. This is I. This is angle of refraction. Vertically opposite angles are equal. This is pole. Now point A is taken. These surfaces are not big. I have drawn a big diagram just to understand the surfaces are like the surface of the lens. Only this thing. So point A is supposed to close to P, but here we have shown that point A, we draw perpendicular from point A on principal axis that meet principal axis point P dash. Let A dash P, AP dash equal to height h. When this point A close to P, this AP and h are equal in length and h will be the arc of circle. Alpha is the angle made by normal with principal axis. Beta is the angle made by ray after refraction, it is produced back here. This ray, reflected ray, actually this side they will not meet, we produce them back. And here is the object. Now our eye is looking this object O. The object O will be seen by this eye here at point I. So here we call I as image of object O formed by this concave surface. Actually this diagram is not given in NCERT book. There is one book with me called Newton Physics, and there is this diagram. No other book. Actually it is difficult to draw this diagram also. It is challenge for students. Actually to draw this diagram, what is the precaution? Take the curvature small. The surface should be curved. बच्चे क्या करते हैं ऐसे ले लेते हैं फिर वो बनता नहीं. Center will be very far away and so on. Many difficulties are there. So now we have to establish here the relation between object distance, image distance from pole, different index, and that is called refraction formula on spherical surface. So here in this diagram, now it is clear that O is the point object on principal axis of concave surface of glass, which is a part of glass slab. Actually we are looking across this and it appears at point I. Here PO will be called object distance U. PI will be image distance V. And PC is equal to R, radial curvature of this sphere. Is that clear? Angle I is the angle of incidence between normal ray and incidence ray. R is the angle of refraction between refracted ray and normal. Now from Snell's law, refractive of glass with respect to air n, refractive index of glass with respect to air n is equal to sin I upon sin R. Sin R. Now, since the surface is small and distances are large, like I am looking at the door and anywhere, so angle I and R are very small. Since angle I and angle R, I and R are very small, so sin I equal to I, sin R is equal to R. I have told many times, when theta tends to 0, if theta tends to 0, sin theta equal to theta, cos theta equal to 1, tan theta equal to theta. But there, remember that angle should be placed in radian, not in degree. Sin 1 degree is not 1. Actually 1 degree I have told equal to 0.0174 radian. And you will find in log table sin 1 degree is this. So here angle should be placed in radian. Sorry, there was some disturbance. So I have told many times. So this equation can be written as n equal to I upon R. So one person has n equal to I upon R, or because sin I है तो sin R, or I equal to n R. Now in this given figure, there is triangle ACO. And actually our aim here is to relate image distance, object distance and real curvature with n. So we need distance along principal axis. In figure, alpha is the exterior angle of triangle ACO. So alpha equal to I plus gamma. Alpha equal to I plus gamma. Or I is equal to alpha minus gamma. Again, there is triangle ACI. In triangle ACI, alpha equal to R plus beta, or R equal to alpha minus beta. 3. Putting 2 and 3 in 1. Putting 2 and 3 in 1, we will get 2 and 3 in 1. I equal to alpha minus gamma equal to n into alpha minus beta. It is simple. Alpha here, n alpha minus n beta. We can rewrite it as n beta minus gamma is equal to n alpha minus alpha, or n beta minus gamma is equal to alpha into n minus 1. Equation 4. Alpha, beta, gamma are again small. Here, since alpha, beta and gamma are small angle, so hence alpha is equal to tan alpha is equal to एक मिनट पर R small angle, so A lies close to P, and hence P dash coincide P. I told you this figure has been elaborated large, but this surface is more like the lens of my goggle. So tan alpha is equal to H upon PC. PC is equal to R. And according to our convention, every distance along axis are measured from pole. Distance is opposite to incidence ray is negative, and in the direction of incidence ray positive. So here alpha is equal to H upon minus R. Similarly, beta is equal to tan beta is equal to H upon Pi is equal to Pi is equal to H upon minus V. Because distance measured from this, rays are going like this, direction ही है, and gamma also equal to tan gamma is equal to H upon PO is equal to H upon minus U. Object distance U से लिखते हैं. Putting alpha, beta, gamma in equation 4. Putting alpha, beta, gamma in equation 4. N into beta H upon minus V, or minus gamma H upon minus U is equal to alpha H upon minus R into N minus 1. Now H cancel, minus sign cancel, so we get it here as N upon V minus 1 upon U. These minus cancel is equal to H cancel, n minus 1 upon r. This is the refraction formula we have derived for spherical surface. Now, dear students, I actually here for simplicity I have done like this. In books and in exam also, they don't say it is glass transparent. Both are transparent medium, both sides. They take index n1 and n2. Here, light going from n1 to n2. So here n will be different index of medium 2 with respect to 1 and 2 upon n1. And then you will write n2 upon n1 is equal to sin I upon sin r. And if I are small, then n1 I equal to n2 r. And by following this I value of I in terms of alpha, beta, gamma, you will get the equation like this: n upon n2 upon v minus n1 upon u is equal to n2 minus n1 upon r. But finally, what happens in books? They say कि n1 is 1 और n2 equal to n. फिर यहीं आ जाते हैं. So I wanted to solve it easily. Now, so we have got the relation between different index n, v, u. From this equation, n upon v comes out to be n minus 1 upon r or plus 1 upon u. When will we use this equation again? The known values will use here with proper sign, while unknown sign will come out from calculation. So for concave surface, if the surface is concave n more than 1, for concave surface, if n greater than 1, v यानी कि distance of image from pole will be negative. Why? This is because here R and U are negative. This is because R and U both are negative. भाई यहाँ साइन पर माइनस माइनस तो v will come out. हाँ, अगर n less than 1 होता फिर सिचुएशन चेंज होगी. And therefore for n greater than 1, imagine convex concave surface, the image in concave surface will be virtual. We remember it. Actually, in different competitive exam, question come on this topic generally. They ask the question from this part. So this was the derivation of refraction formula. This is called refraction formula. N upon V minus 1 upon U is equal to N minus 1 upon R. In तो board exam तो derivation भूल जाते हैं. In board exam they ask you question, but in competitive exam they ask something other relating this. I will be telling you. Thank you.